Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, I will go over a rather simple concept, not really a rule, but it is using the chain rule that we can make our differentiations a lot easier. So let's get started with the daily practice. So the daily practice states that f of x is x cubed plus x squared plus x plus 1, and g of x is 3 times f of x squared. And we want to find g prime of x. And the first solution would just to bash it out, just plug that in. If we have g of x, we have 3 times this x cubed plus x squared plus x plus 1 squared, and just use the power rule and the constant rule and the constant multiple rule over and over again. You can get the answer, yes, but it takes a very long time and you want to know easier solution. The second solution is to use the chain rule. The chain rule is actually, so if we want to find the derivative of g with respect of x, then we simply have this, and we basically want to find this composite function, and the outside function is actually, let's name that h of x is actually 3x squared, and we plug in that f of x. So we want to find the derivative, so derivative of x is actually equal to h of f of x. So that's what we want to find. So we want to find the derivative of this. And the derivative of this is basically taking the derivative of this part. So that is equal to this h, so that would be equal to this h right over here of f of x, that is 3, and we want x squared and we want to take the derivative of that, so 3 times 2 times this x, so x squared, so we want the f of x here and apply the chain rule. Don't forget to take the derivative of this function as well. So that will be times 2x, actually times 3x squared plus 2x plus 1. And this is just the normal f of x, so that will be 6 times x cubed plus x squared plus x plus 1 times 3x squared plus 2x plus 1. And you just have to factor it out. Actually, the reverse factor, so multiply it out. And that would be, so do that, so that will be 3x fifth plus this 2x fourth plus x cubed plus this, so that's 3x fourth plus 2x cubed plus x squared plus 3x cubed plus 2x squared plus 1 plus 3x squared plus 2x plus 1. Let's actually write this a bit in more organized way. So we need to move this portion down to over here. That's more organized, and we need to erase that parentheses down to here. And that would equal to 3x fifth plus 5x fourth plus, that's 6x cubed plus 6x squared plus, that's actually x because that's x times this 1. So that's x plus 3x plus 1, and the last step we just have to multiply it out. So plus 30x fourth plus 36x cubed plus 36x squared plus 18x plus 6. Now let's take a look at implicit differentiation. Implicit differentiation is actually just a concept using the chain rule mostly, and we just want to make sure that, hey, this works. And it's not really a rule and it's very easy to understand, but when you actually use it, you have to know that it works and it's actually very convenient. Implicit differentiation, unlike explicit differentiation, it is basically taking two variables. One is the x value on the graph, one is the y value, and no matter how they go, we just take the derivative on both sides of an equation and get the dy over dx term out. So, let's look at an example to feel this, because this is not an easy to understand concept, I guess. If we have, let's say, a circle that's normally very hard to deal with because we just simply have a circle. Let's see, x squared plus y squared. Let's say just use 1, and the graph would look like this. I want a full circle. Graph would look like this with the center at the origin. And if we have this, we can label that this is -1, -1. If you want to differentiate this normally, then we just simply have to do, that is y squared, that's 1 minus x squared, and be careful when you actually try to square root this, because it is actually defined on both positive y and negative y. We just need to make sure that we add the plus or minus sign over here. Well, that's definitely doable. We can split it into two cases. So that's 1 minus x squared. That's y is equal to -1 minus x squared. And for that, we can just simply take the derivative of both equations. And let's say we take the derivative of this. Then for this, we just simply get that y prime, or just write it as dy over dx, is equal to this thing using the derivative. So that's we can do, let's move this a little bit away. So we can do the derivative of this. So that's square root of 1 minus x squared. We can rewrite this as, as that to the 1/2 power, so that we can use the power rule. And over here, we need to use the chain rule, because this is actually not x. This is actually 1 over x squared. And that would actually be equal to, so this thing is not differentiated, so 1 over 2 square root of, actually let's write it this way for beginners, so that you can see this is the power rule. 1 minus x squared to the -1/2 power times this thing derivative, so dx of 1 minus x squared. And that we just can have 1 over 2 square root of 1 minus x squared. And the numerator, we can differentiate this. This is just equal to negative. That is 1 over x squared. That would be -2x. And we can write this in both x and y terms because in implicit differentiation, we really don't have a difference between x and y, and they're just two variables. And we can see that y is this thing over here. So that's negative 2x minus over 2y, and that is just equal to negative x over y. If you look at the graph, it makes sense because if you have something like this line over here is just the tangent line of this, and if you can do some trigonometry, you can get that this slope is actually 2 because we know that this is perpendicular. You can investigate this a little bit more and leave in the comment section if you get it right. Let's do the other part now. The other part should be relatively easy now. The other part is just dy over dx is equal to this same thing basically, but with a negative. That is just equal to this. So negative that, can bring that out to get this 1 minus x squared of this negative 1/2 and like something like this, and times the derivative of, because we use the chain rule here, and that would be equal to this thing, square root of that, times this 1 minus x squared derivative, so that's just negative 2x again, just negative 2x, and this is equal to, so these negatives cancel out, we get x, and these 2's cancel out, get x over this. But in this case, our y is actually negative that, so if we want to convert that into y, we actually need to add a negative, so that's x over negative y, and that's negative x over y. That is exactly matching our first case, so we can just combine them and say that dy over dx is equal to negative x over y. But there is a much faster way of doing this. That involves using implicit differentiation. Implicit differentiation, if you recall our original equation, that's something like this, x squared plus y squared is equal to 1. And if we take the derivative on both sides, we just get this. And why does that work? Because if we have two things equal to each other, their function, so if we have, let's say, something like this, and if you have this equal to this, then their value must be same no matter how x and y changes, because they're equal. And if we take the slope of both of them, that means their slope is equal. If you have a function, let's say like this, and if you have a function overlapping it, does that mean they're equal? Their slope at every point is equal? Well, obviously they are. So implicit differentiation works. Now, let's just take a look at how do we differentiate this thing. Well, the other rules still apply, the constant rule, the addition, the sum rule. So that's just that x squared plus the derivative of y squared, and that is equal to, this is just equal to 2x, but because this is with respect of x, we actually need to use the chain rule over here. Let's say this y is equal to some function of f of x squared. Use this chain rule. Actually, we can think of this as like a function of y of x, but I'm going to use the placeholder for f of x, and this is just 2x plus this this thing squared, so that's just 2 f of x times this f prime of x. And recall that we defined f of x to be y, so that's just 2x plus 2 times y times this f prime of x, which is what we want, dy over dx. That's equal to 0. And next step, we can just simply move this to the other side. We get 2y times dy over dx, which is what we want, is equal to negative 2x, and so dy over dx is equal to negative 2y over 2x over 2y, and if we cancel out the 2, then we just have negative x over y. And that matches our conclusion with explicit differentiation. That also proves that doesn't count as proof because we only use one example of it. That also shows that this implicit differentiation technique works. Thank you for watching this episode of Interstigation, and I will see you in the next one. Goodbye.